All right, so for this question, the first thing to notice is that you have an inequality. So the process is not going to be exactly the same as if it was an equation. Instead, what we're going to do is we are going to solve f equal to 0. So we're going to take this whole left-hand side and call that our f and say that we're really trying to solve f is less than 0. And so to do that, we're first going to solve it as if it was an equation. That's going to give us something known as the boundary points, and then we are going to test a number into each of those boundary points. All right, so to start off, to solve this equation, because it is a quadratic equation, again, the highest power is 2 here, we would start maybe by trying to factor it. So we would say, okay, this is s minus 7 and s plus 2. Again, thinking about the factors of negative 14 that sum up to negative 5. So 1 times negative 14, have to add to negative 5. That's going to be negative 7, positive 2. And then we can put, because of the 1, we can put it as s and s, and then equal 0. Now that it's factored, we set each of the factors equal to 0. We get s is equal to 7, s is equal to negative 2. Now, those two numbers are what we call the boundary points, and they are going to become the two numbers that we are going to put on our number line. So on our number line, we have negative 2 and we have positive 7, our two boundary points. And what we need to do is we now need to test a number in each of these three intervals. So for the interval from negative infinity to negative 2, we can pick any number we want to except for negative 2. So I might pick, let's say, negative 3. Now, there's lots of different ways to test negative 3. What you could do is you could go back to the very beginning of the problem, the s squared minus 5s minus 14, plug in the negative 3 there. You could also go to this s minus 7, s plus 2, the factorization, and plug it into there. So it doesn't matter which one you plug it into, just as long as you're plugging it into some version of the polynomial. So here I'll plug in negative 3 minus 7, negative 3 plus 2. So I like to plug it into the factored form just so the arithmetic isn't so involved. So I get a negative 10, a negative 1, so that gives us a positive overall. So we have a positive on the first interval. Now this does get a little tedious because then what you have to do is you have to test another number from negative 2 to 7. So I might plug in, for example, 0 into that polynomial to see if it's positive or negative. And then from 7 to infinity, I have to test a number. So I might plug in, let's say, 10. Now, if you're under time pressure and you just want an easy way out, what you can do is you can go on your calculator and you can plot that function. And it's even not plotting the function, you can just type in like the x squared minus 5x minus 14. And then remember what we can do is we can hit second table, and that gives us a whole table of values. So what I could do here is, like, when I decide that I'm going to test negative 3, I could go to my table and say, okay, at negative 3, it's giving us a positive 10. So that would tell me that it's positive here. And then I could say between negative 2 and 7, I want to test. So let's say I would test 0. So I would cursor down on my table, see that 0 corresponds to a negative. And then from 7 to infinity, I would cursor down on my little table. Maybe I plug in 9 and I get a positive. So that tells us we have a positive. Okay, so there's lots of ways to get that table created. You can plug into the original polynomial, the factored polynomial, or you can type in the polynomial and hit second table, and that will also be a way that you can evaluate the function at these three different intervals. Now, once you get your chart, you're not quite home free yet, because we need to try to use this chart to answer the given question of this polynomial is less than 0. So we want f to be less than 0. So if we look at our chart, the interval where f is less than 0 is from negative 2 to 7. Now, the chart just tells us the actual numbers, the fact that it's negative 2 and 7. The reason why I'm putting parentheses here and parentheses here is because of the fact that it's strictly less than. So because it's strictly less than, I'll use parentheses. And I just want to point out, if the question, and this is not the question that was given here, but if, let's say, the question had been f greater than or equal to 0, then in that case you would do the same process, but now when you get to your boundary, what you would do is you would say, okay, it's positive from negative infinity to negative 2, and it's also positive from 7 to infinity. Now your infinities, it's always non-negotiable. They have to have the parentheses. But the finite numbers could potentially have a parenthesis or a square bracket. So if the question had been greater than or equal to, then because of that equal to, I would not put a parenthesis here, even though in the table it has a parenthesis. I would put a square bracket and a square bracket with a union. And that would be my answer if the question was f greater than or equal to 0.